Hello viewers, in today's session we are going to discuss one important problem from three-dimensional geometry, and here we are going to discuss this problem which is from a straight line, and here the topic is to find the equation of the perpendicular from a point to a given line and the coordinates of the foot of the perpendicular, right? So here we have this problem, that is we have to find the equation of the perpendicular from the point whose coordinates are 2 comma 4 comma minus 1, and a perpendicular is drawn from this point to this line, the whose equation is x plus 5 is equal to y plus 3 over 4 is equal to z minus 6 over minus 9. And moreover we have to find out the coordinates of the foot of the perpendicular, right? So let us first draw a rough diagram to solve this problem. So here we are given a line, and suppose this line is L, and the equation of the line L is given as x plus 5 over 1. So here we can take 1, and then we have y plus 3 over 4 and z minus 6 over minus 9. And here we are given a point, say A, whose coordinates are 2 comma 4 comma minus 1, right? And suppose we drop a perpendicular from this point A to this line L, and suppose this point P is the foot of the perpendicular, right? So AP is perpendicular to this line L, and the equation of the line L is given by this equation, right? So let us take a scalar lambda here, right? So the purpose of taking this lambda is to find out the coordinates of this point P, which lies on this line L and this line, that is AP. So the coordinates of this point P may be obtained from this equation, that is the concept of a general point on a line. So we can now write x plus 5 over 1 is equal to lambda. So we'll frame three equations. So we have y plus 3 over 4 is equal to lambda, and z minus 6 over minus 9 is equal to lambda. So solving these equations for x, y and z, we can now write x is equal to lambda minus 5, then y is equal to 4 lambda minus 3, and then z is equal to minus 9 lambda plus 6, right? So we have the coordinate, that is x comma y comma z, which is known as the coordinates of the general point on this line L, right? And for some special or specific value of lambda, we can have the coordinates of this point P, right? So x, y, z are given by lambda minus 5, 4 lambda minus 3, and minus 9 lambda plus 6. So here we can now write the coordinates of point P as lambda minus 5, 4 lambda minus 3, and minus 9 lambda plus 6. So for some particular value of lambda, we can have the coordinates of the point P. So now let us obtain the direction ratios of this line AP, right? So the DRs of the line AP can be obtained by subtracting these coordinates, right? Because we know that if we have a line and if we have 2 points, say A and B, and this point is x1 y1 z1, this point is x2 y2 z2, then the direction ratios of AB are given by x2 minus x1, and y2 minus y1 and z2 minus z1, right? So here we can take here x1 y1 z1. This point A can be taken as x1 y1 z1, and this point P can be taken as x2 y2 z2. So the direction ratios of AP are given by lambda minus 5 minus 2. Then we have 4 lambda minus 3 minus 4, and then minus 9 lambda plus 6 minus 1, right? So we can now write a lambda minus 7, then we have 4 lambda minus 7, and then we have minus 9 lambda plus 7. So these are the direction ratios of this line or this perpendicular AP, right? Now the direction ratios of this line L are obtained from the denominators of these three quantities. So the direction ratios of the line L are given by simply 1 comma 4 comma minus 9, right? So now we have the direction ratios of AP and the direction ratios of the line L. So now let us apply the concept of perpendicularity of two lines, right? Suppose two lines are perpendicular and their direction ratios are A1, B1, C1, and A2, B2, C2. And if these two lines, say L1 and L2, are perpendicular, then the condition is that A1, A2 plus b1 b2 plus c1 c2 is equal to 0. So here the direction ratios of AP are given by these numbers, and the direction ratios of the line L are given by these numbers. So here we can take a1 b1 c1 as lambda minus 7, 4 lambda minus 7 minus 9 lambda plus 7, and a2 b2 c2 can be taken as 1 comma 4 comma minus 9. So let us apply this condition. So we have AP perpendicular to the line L. So we have lambda minus 7 times 1 plus 4 lambda minus 7 times 4, and then we have minus 9 lambda plus 7 times minus 9, and this is equal to 0. So let us solve this equation in lambda. So we have lambda minus 7, then we have 4 times 4 is 16 lambda minus 4 times 7 is 28, and here we have minus minus plus. 9 times 9 is 81, so we have 81 lambda minus 63 is equal to 0. So now we can collect the terms containing lambda. So we have lambda plus 16 lambda plus 81 lambda, and then we have here a minus 7 minus 28 minus 63 is equal to 0. So now if we add these three numbers, then we have 98 lambda, and here we have minus 7 minus 28 minus 63, and this is also minus 98. So this is equal to 0. So now from here we have 98 lambda is equal to 98. So lambda is 98 over 98, that is equal to 1, right? So for lambda is equal to 1, we can now easily find out the coordinates of this foot of the perpendicular. So P is the foot of the perpendicular. So taking lambda is equal to 1 over here, the coordinates of the point P are given by 1 minus 5. Then we have 4 times 1 minus 3, and then minus 9 times 1 plus 6. So we can now write the coordinates of point P as 1 minus 5 is minus 4, then this is 4 minus 3, that is 1, and minus 9 plus 6 is minus 3. So these are the coordinates of the foot of the perpendicular, that is the point P. So now the equation of this perpendicular AP can be written as x minus x1 over x2 minus x1 equal to y minus y1 over y2 minus y1, and z minus z1 over z2 minus z1, right? So this is the 2 point form of the equation of a straight line. So when we have 2 points, that is say x1 y1 z1, and this is x2 y2 z2, then the equation of AP is given by this equation, right? So here we can take x1 y1 z1 as 2 comma 4 comma minus 1, and x2 y2 z2 as minus 4 comma 1 comma minus 3. So this is x2 y2 z2, and this is x1 y1 and z1. So the equation of AP is given by x minus 2 equal to y minus 4 is equal to z minus minus 1, and in the denominator we can write x2 minus x1. So we have minus 4 minus 2, then we have 1 minus 4, and then we have minus 3 minus minus 1. So this is x minus 2 over minus 6. This is y minus 4 over minus 3, and then we have z plus 1 over minus 3 plus 1, that is minus 2, right? And here we can see that these denominators have the negative sign. So eliminating this negative sign by multiplying throughout by minus 1, so we can also write x minus 2 over 6, y minus 4 over 3, and z plus 1 over 2, right? So this is the required equation of this perpendicular AP. Now we can also find out the length of the perpendicular AP by using the distance formula. So AP is given by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this is the distance formula. So substituting the values, we have minus 4 minus 2, that is minus 4 minus 2 square. Then we have 1 minus 4 square, and then we have minus 3 plus 1 square, right? So this is square root of minus 6 square. This is square of minus 3, and then we have here minus 2 square. So this is 36, this is 9, and this is 4, right? So we have now square root of this is 13, 13 plus 16 is 9, and here we have 4. So this is positive 7, right? So the length of the perpendicular AP is given by 7 units. Hello viewers, in today's session we are going to discuss another important conceptual problem from three-dimensional geometry, and here we are going to take up this problem from the topic that is intersection of planes, right? So here we have to find the equation of the planes passing through the line of intersection of the planes, having equations x plus 2y plus 3z minus 5 is equal to 0, and 3x minus 2y minus z plus 1 is equal to 0. and cutting off equal intercepts on the x and z axis, right? So here we are given the equations of two planes, and we have to find out the equation of the planes passing through the line of intersection of these two planes and cutting off equal intercepts on the x and z axis. So here we'll solve this problem using the concept of intercept form of the equation of a plane. So let us start. So now let us denote this plane by P1 and this plane by P2, right? So let us draw a rough diagram here. Suppose this is our plane P1 and this is our plane P2, right? And we have to find out the equation of the plane which passes through the line of intersection of these two planes P1 and P2, right? So here the plane which passes through the line of intersection of these two planes is this line, and here we have the plane, the required plane, and let us call this plane as P, right? So P passes through the line of intersection of planes P1 and P2, and always remember whenever two lines intersect, then the lines intersect at a point, right? But when two planes intersect, they always intersect in a line, right? So the equation of the plane P which passes through the line of intersection of plane P1 and P2 is given by P1 plus lambda P2 is equal to 0. So this is the equation of plane P which passes through the intersection of these two planes P1 and P2 for some value of lambda, and here lambda is a scalar, and we'll find out the value of this lambda by using this condition which is given as cutting off equal intercepts on the x and z axis. So let us substitute the value of P1. So the plane P1 is x plus 2y plus 3z minus 5, and then we have lambda times 3x minus 2y minus z plus 1 is equal to 0. So let us rearrange this equation. So we have x plus 3 lambda x, and then we have 2y minus 2 lambda y, and then we have here 3z, and then we have minus lambda z, and then we have minus 5 plus lambda is equal to 0, right? So here we can take x common, so we have 1 plus 3 lambda, then we have here y common, so we have 2 minus 2 lambda, then here we have z common, and we have 3 minus lambda, and let us take this term to this side. So we have here 5 minus lambda, right? Now let us divide both sides by 5 minus lambda, because we have to convert this equation into the intercept form of the plane, right? So we have x, then we have 1 plus 3 lambda over 5 minus lambda, y 2 minus 2 lambda over 5 minus lambda, and then we have z 3 minus lambda over 5 minus lambda, and here we have 1, right? And obviously here we can also write this equation as here we can write 5 minus lambda over 1 plus 3 lambda, right? So taking this term, that is 1 plus 3 lambda, to the denominator of 5 minus lambda, and similarly here we can write y over 5 minus lambda over 2 minus 2 lambda, and then we have here a z over 5 minus lambda over 3 minus lambda, and this is equal to 1, right? So what we have done here, we have written the equation of the plane P, which is given by P1 plus lambda P2 is equal to 0. Substituting the value of P1 and P2 in this equation, we have arrived at this equation. So the purpose of writing this equation is that we know that the intercept form of the equation of a plane is x over a plus y over b plus z over c is equal to 1, right? So this equation represents the equation of a plane which cuts the intercept a, b and c on the axis, that is x, y and z axis. So a is the length of the intercept cut by the plane on x-axis, b is the length of the intercept cut by the plane on y-axis, and c is the length of the intercept cut by this plane on z-axis. So now the equation of the plane P in this form, that is the intercept form, is given by this equation, right? So that's why we have written 1 plus 3 lambda in the denominator of 5 minus lambda, and similarly 2 minus 2 lambda in the denominator of 5 minus lambda, and 3 minus lambda in the denominator of 5 minus lambda. So the length of the intercept cut by this plane P on the three axes, that is x-axis, y-axis and z-axis, are given by comparing these two equations. So the value of A is 5 minus lambda over 1 plus 3 lambda. B is 5 minus lambda over 2 minus 2 lambda, and C is 5 minus lambda over 3 minus lambda, right? So now in the given problem, we are given that the equation of the plane passing through the line of intersection of these two planes and cutting off equal intercepts on the x-axis and z-axis, right? So a is the length of the intercept cut by this plane P on x-axis, and the length of the intercept cut by this plane P on z-axis is given by C. So here we are given that A is equal to C. So the length of these two intercepts are equal, because here we are given that cutting off equal intercepts on the x and z axis. So we can now equate these two terms, that is 5 minus lambda over 1 plus 3 lambda is equal to 5 minus lambda over 3 minus lambda. So now let us solve this equation, right? So taking the cross multiplication here, we have 5 minus lambda, 3 minus lambda, and then we have 5 minus lambda, and here we have 1 plus 3 lambda. So taking this term to this side, we have 5 minus lambda, 3 minus lambda minus 5 minus lambda, and here we have 1 plus 3 lambda is equal to 0, right? Now taking 5 minus lambda common, so we have 5 minus lambda, and here we have 3 minus lambda minus 1 plus 3 lambda, and this is equal to 0. So we can solve it. 5 minus lambda, Here we have 3 minus lambda minus 1 minus 3 lambda is equal to 0. So this is 5 minus lambda, and here 3 minus 1 is 2, and here we have 4 lambda, right? So now this is the product of two linear factors in lambda. So we can have 5 minus lambda is equal to 0, and from here we have 2 minus 4 lambda is equal to 0. So from here we have lambda is equal to 5, and from here we have 2 is equal to 4 lambda, and lambda is equal to 2 over 4, that is half, right? So we have obtained two values of lambda, that is 5 and 1 over 2. So now to obtain the equation of the planes, we have to substitute the values of lambda in this equation, right? That is p1 plus lambda p2 is equal to 0. So here we can take this equation as equation number 1. So let us first take lambda is equal to 5. So we have x plus 2y plus 3z minus 5, and then we have 5 and 3x minus 2y minus z plus 1 is equal to 0. So simplifying it, we have x plus 2y plus 3z minus 5, and this is 15, and then we have 10y, and then we have 5z, and here we have 5, right? So 15x plus x is 16x, then we have 2y minus 10y is minus 8y, 3z minus 5z is minus 2z, minus 5 and 5 get cancelled, right? So let us divide throughout by 2. So we have here 8x, then we have here y, and here dividing both sides by 2, here we have 4, and then here we have z, and this is equal to 0. So this is the first equation of the plane passing through the line of intersection of these two planes and cutting off equal intercepts on the x and z axis. Now let us substitute lambda is equal to half in this equation number 1. So now we have x plus 2y plus 3z minus 5, and lambda is half, and we have 3x minus 2y minus z plus 1 is equal to 0. So now multiplying throughout by 2, we can now write here 2, then we have x plus 2y plus 3z minus 5 plus 3x minus 2y minus z plus 1 is equal to 0. So we can now write 2x plus 4y plus 6z minus 10, and this is 3x minus 2y minus z plus 1 is equal to 0. So now 2x plus 3x is 5x, then 4y minus 2y is plus 2y, and 6z minus z is plus 5z, and minus 10 plus 1 is minus 9, and this is equal to 0. So this is the equation of the second plane which passes through the line of intersection of these two planes and cutting off equal intercept on the x and z axis. So here we have two equations of the planes. It means there are two planes which passes through the line of intersection of these two planes, that is p1 and p2, and cutting off equal intercept on the x and z axis. So this equation corresponds to lambda is equal to 5, and this equation corresponds to lambda is equal to half. So here the two planes are given by these two equations. right? So let us first convert this equation into the intercept form, right? So we can write here 5x, then we have plus 2y plus 5z is equal to 9. So taking this negative 9 to the right hand side, and let us divide both sides by 9. So we have 5x over 9, then we have 2y over 9, and then we have 5z over 9 is equal to 1. So we can also write this equation in this form as x over 9 by 5, then we have y over 9 by 2, and then we have z over 9 by 5 is equal to 1. So if we compare this equation with this one, then the value of the x-intercept is a is equal to 9 over 5, b is 9 over 2, and c is 9 over 5. So the values of x-intercept and z-intercept both are equal, that is 9 over 5 and 9 over 5. So now let us look at this plane. So here we have 8x minus 4y minus z is equal to 0, right? So now if we closely observe this equation of the plane, then we can see that this plane passes through the origin, right? That is 0 comma 0 comma 0, because the coordinates of the origin satisfies this equation, because here we have 8 times 0, 4 times 0 minus 0 is equal to 0, right? So this plane passes through the origin, right?